Hello, my name is Afam bin Afrizol, and I'm going to be presenting the network design overview, the IPv4 and IPv6 addressing scheme, and IPv4 and IPv6 subnetting details. Over here, you can see our whole entire network. If we move on to the left side, you can see the pink and blue box. Over in the pink box, you can see there's a IPv4 network that has been configured. And also in the blue box, you can see the IPv6 network that has been configured. If we move on to the right side, you can actually see a dual stack network existing in the purple box. Inside the purple box, there's a blue box and a pink box. In the blue box, there's the IPv4 configurations, and over in the pink box inside the purple box is the IPv6 configurations. If you see at the bottom, you can actually see another box which is green is the services configurations that have been set up for the entire network. And in the yellow box are the switches that connects all of this together. Let's move on to the IPv4 addressing scheme. So our addressing scheme has been set up using our own date of birth, which is the 20th of January 2005, the 24th of the 4th month of 2005, the 27th of the 12th month of 2005, and the 31st of the 10th month of 2005. You can see the network addresses and the default gateway that have been set up using our date of birth. Similarly to the IPv6 addressing scheme, you can see how we use our own date of birth to make our own IP addresses. Moving on to the IPv4 subnetting details, over here you can see the entire subnetting details of our IPv4 network. For network 2, you can't see any because network 2 entirely uses IPv6. So if we move on to the IPv6 subnetting details, you can see the network 2 IPv6 details. Okay, that's all from me. Thank you.
Hello everyone, today I will be representing about dual stack networking. In this part of the project, the goal is to ensure that the network can provide access to essential services such as the web server, DNS server and email server, and also the FTP server. Our purpose of the dual stack is to configure our network to support both IPv4 and IPv6 simultaneously. But since the different device and application may rely on either IPv4 or IPv6. As you can see in the diagram, each server has been assigned both an IPv4 and IPv6 address. While IPv4 ensures backward compatibility with legacy device, IPv6 provides scalability and modern features such as larger address space and improved routing. We use different subnets to separate the services, which improve organization, simplifies troubleshooting and enhance security. With this configuration, any device that routes into our network, whether it uses IPv4 or IPv6, can successfully access all the services we have set up. This ensures smooth connectivity and demonstrate the effectiveness of the dual stack environment. In summary, dual stack networking allows us to bridge the gap between current IPv4 system and the future of IPv6. By implementing it here, we have ensured that our servers are reachable, reliable, and ready for diverse client devices. That's all from me. Thank you.
Hello, my name is Muhammad Buhari and I will be presenting the wireless and also the radius configuration. So, as you can see, this is our topology for the wireless network. We have a DHCP server that automatically assigns IPv4 addresses and a radius server that used to authenticate every wireless devices that connects to the network. For the IPv6 on the device, we use Slack feature from the router since it's a lot simpler. So as you can see, this is our DHCP configuration and our radius configuration. For our DHCP, we use my date of birth, which is 31st of October, and we start the IP address at .10 so that we were able to allocate some part of the IP addresses to the DHCP server, radius server, and some of the router as well. So as you can see, we only have 246 maximum devices that could connect to this network lah. Now we have the radio server. Radio server, as you can see, we have the marketing, engineering, and guest router information. So the router information should match the one in here to make sure that the connection can be established. And down here is all the user names and also their passwords for the wireless authentication. Okay, as you can see, this is the configuration of all three of the routers. One is gas, one is engineering, and the other one is marketing. So if you want to go on, I can show you our server right now. So if you go to PC0, as you can see, you go to the wireless section, you can connect to multiple networks. One is the engineering, one is marketing. Both are running on WPA2 Enterprise. So for example, here it is now running on the marketing. Say if I click connect, we fast forward a bit, and you can see it's now connected to the engineering. And so for example, this one, PC2, we have the gas and also the engineer. Oh no, this one you have the gas one because it's the gas PC. For example, they can connect to the gas. So yeah, that's on my part. Thank you.
Hello everyone, today I want to explain about the high availability core network with multi-switch redundant topology, spanning tree, and lastly about routing configuration. So this is our overview about the multi-switch redundant topology. It is set up for the spanning tree protocol that avoids the loops from one place to another to a specific destination to avoid loops. So lastly, this is our routing configuration. The routing configuration using the OSPF that is dynamically and recommended for routing purposes. Thank you. That's all from me.